So this video lesson is all about quadrilaterals, specifically about classifying quadrilaterals. And we're going to start this lesson with a bit of a review, and that is of different types of lines. And in terms of different types of lines, what we mean is what lines do when they interact with each other. We have some lines that cross at some point. Now, lines only cross at one point. Lines that do cross are called intersecting lines because they have what we call an intersection. Lines that intersect in a specific way, that is, at right angles, are called perpendicular lines. And what you see down here, which looks like a red square, is actually the red corner that is often used in these video lessons to denote a square corner or a right angle. There just happen to be four of them there at one time. And finally, if lines never intersect, and we're talking never in any direction, moving along both lines forever, will ever intersect, are called parallel lines. And to represent that two lines are parallel, we use these arrows on the lines. And so using those, we represent that the lines are parallel. If you see one arrow in each of two lines, it means they're parallel with each other. We could have multiple arrows on those lines, but identical arrows on lines indicate that they are parallel. So with that review, we go back to now what we came here for, which is classifying quadrilaterals. Now, first we need to remember that a quadrilateral, with the quad at the beginning, meaning four, and lateral, meaning side or to the side. A quadrilateral is a polygon with four sides. Again, quadrilateral. And so when we talk about types of quadrilaterals that we had, with triangles we used angles and we used whether or not sides were equal, and we do that to an extent with quadrilaterals, but not nearly to the extent that triangles. We start with looking at parallel sides. Now, if a quadrilateral doesn't have any parallel sides, we just call it a quadrilateral. If a quadrilateral has one set of parallel sides, we call it a trapezoid. And a trapezoid has exactly one pair of parallel sides, but not two. So one set of sides is parallel, another set is not. And here we can see the arrows that represent the top and bottom edges of the trapezoid are parallel. We call these the bases of a trapezoid. And if two sets of sides are parallel, then we call it a parallelogram. And here you can see that I've changed the arrows. Two arrows are black, which is what we've seen. And then on the other two sides, we have two red arrows to represent that these sides are parallel. So we can clearly tell which sides are parallel and which aren't. We have our arrows there to represent that they are parallel, and we call these a parallelogram. Exactly two pairs of parallel sides. Now, once we get past the idea of parallel sides, then we start looking at angles, about side lengths and angle types. And so if we just look at side lengths, a quadrilateral that just has two sides that are equal doesn't really indicate anything at all. What we're looking for is perhaps four sides that are equal. And if it is a parallelogram with four equal sides, we call it a rhombus. Now, it doesn't have to have square corners. It can have any angles that we want it to have. But a parallelogram with four sides that are a parallelogram that has four sides and all of those sides are of equal length is called a rhombus. Now we get to the idea of a rectangle, and that is just a parallelogram with four right angles. Notice that there are some side marks here, but the only requirement to being a rectangle is to be a parallelogram with four right angles. As a result, we have the opposite sides being equal, but the most important part is that there are four right angles. So again, parallelogram. I haven't jotted on here, but we'll take for granted that these are parallel sides. The top and bottom are parallel, and the left and right are parallel. With four right angles is called a rectangle. And finally, if we combine the two, a parallelogram with both four sides of equal length and four right angles gives us a square. So a square is a parallelogram with four equal sides and four right angles. So these are the different types of quadrilaterals that we have. When we look at parallel lines, we can separate them into either generic quadrilaterals, trapezoids, or parallelograms. And then even further within the parallelograms, we can classify them as either rhombi, which is the plural of rhombus, rectangles, or squares. And so just like when we looked at classifying triangles, we're now going to ask the question, what characteristics do all quadrilaterals have in common? Now that includes if the quadrilateral is a rhombus, a trapezoid, a square, a rectangle, a parallelogram, or just a generic quadrilateral that doesn't fit into any of those categories. Well, of course, they all have 4 sides and 4 angles. That is the definition of a quadrilateral. A quadrilateral is also sometimes referred to as a quadrangle, meaning 4 angles, rather than a quadrilateral, meaning 4 sides. The sum of their angle measures is always 360 degrees, no matter the type of quadrilateral. That is the same for a square, for a rectangle, for a generic quadrilateral that doesn't fit into any of those. It shouldn't have a curved side, pretend that's straight. Any of them, they all have 360 degrees. So based on the fact that they all have 360 degrees, and we know what the markings are for equal sides and parallel lines, so we can identify what these quadrilaterals are. For the next 4 problems, you're going to go ahead and pause the video and classify the polygons and find the missing sides or angles. Now these are all quadrangles, and number 3, you can see behind the writing that there's a little line off to the side. Well, I don't want you to worry about the line off to the side, and you don't really even have to classify the one on the bottom because I haven't given you the information there, but I want you to try to figure out all the missing sides or angles. There are X's, Y's, and Z's there to indicate which ones you should try to work with, and then classify the polygons as best you can. And of course, here we are with the words faded into the background so you can see all of the sides. Go ahead, work on 1, 2, 3, and 4. So for number 1, we don't have any side lengths. We see that these sides are parallel. So we can immediately classify this polygon as a trapezoid because we see that the 2 opposite sides are parallel. Now the other sides are not parallel, but we can see this one right away. And so now we need to find out what the measure of this angle x is. So the 3 other angles that we have 125 degrees, 45 degrees, and 105 degrees. So what we need to do is find the total measure of those and find out how far that is from 360, which is the total measure of angles in any quadrilateral. Well, I'm going to write this out as an equation here. X plus 125 plus 45 plus 105 has to be equal 360. Now, I could subtract all of these away at the same point and leave x alone on the left side of that equation there, but I am going to notice that 125 plus 45 is 170, plus 105 is 275, so I'm going to take this time and subtract 275 from both sides. Because when I subtract 275, I can get rid of all of these at once. Just be left with x is equal to 360 minus 275, which is 85 degrees. So the measure of that missing angle is 85 degrees. Now, let's take a look at number 2. Number 2, we're looking for 3 different things here, x, y, and z. X and y are sides, z is the missing angle. Now we can see that there are marks on each of the sides that indicate the 2 sides are equal. The x side has a vertical green mark, which is the same as the side with 175 meters, so x is equal to 175 meters. Y is 2 blue horizontal marks, which is the same as the side with 60 meters. So y is 60 meters long. And finally, we need to look at z. Well, we have 3 right angles so far, and if we have 3 right angles in a quadrilateral, it turns out we're always going to have a 4th, because z plus 270, which is the sum of 3 of those kinds of angles, 3 of the right angles, must equal 360. Subtract the 270 away, and you're left with z equals 90. Z is, in fact, a right angle. Looking down at number 3, we see that two angles are right angles. We don't see anything about parallel sides, so we're not going to try to classify this. But we see that we have two angles that are 90 degrees. This adds up to 180 degrees over here with these angles. We'll keep this off to the side. And now we have x and y. Well, normally with only two angles, we can't find out exactly what the other two angles are. But here, we have the advantage of seeing this line extended. X and 120 degrees are complementary. So x plus 120 has to equal 180. Subtract 120 from both sides and you get x equals 60 degrees. And finally, when we try to find y, we have y plus 60 plus 180 equals 360. When we subtract away 240, which is the sum of 60 and 180, we end up with y is equal to 120. And finally, for 4, we see that two lines are parallel. We're not sure about the other two. This is either a trapezoid or a parallelogram. The two sides on the top and bottom are equal because we can see the vertical green line, so that means that x is equal to 13 inches. The two sides on the left and right are both have two diagonal orange lines, so they are the same length. That means y is equal to 7 inches. And finally, we're left with the angle. We can see that we have two angles of 45 degrees and one angle of 135. If you add all that up, that becomes 225. So I'm going to take z plus 225 is equal to 360. Subtract 225 away. And finally, we are left with z is equal to 135 degrees. Now, you may have classified this as a trapezoid with only one set of parallel lines, but if I told you that these lines were also parallel, what would you now call this? It is a parallelogram. And for number 2, with 4 right angles, we said that this is a rectangle. So that is it, classifying quadrilaterals.